Good morning all. Today we are going to discuss biofuel. Biofuel is any fuel that is derived from the biomass, so which is made from renewable energy source like a plant, algae or animal waste. These are actually renewable alternative to fossil fuel and it emits less carbon dioxide. It replaces liquid fuel like gasoline, diesel and jet fuel. Example of this biofuel is ethanol, biodiesel, solid biofuels, biogas, etc. And these type of fuels are promoted as cost-effective, environmental friendly alternative. So next we will see the different type of biofuel. So biofuel are mainly classified into gaseous and liquid biofuel. The gaseous biofuel are two types, biogas and syngas. Biogas is methane generated in the process of anaerobic digestion of organic matter by anaerobes, and syngas is a mix of carbon monoxide, hydrogen and other hydrocarbons, which is produced by partial combustion of biomass. Next is the liquid biofuel. Liquid biofuel is divided into bioethanol and biodiesel. Bioethanol is a type of alcohol produced by fermentation, often from carbon dioxide made in sugar or starchy crop like corn, sugarcane, sweet sorghum. And biodiesel is most commonly used in Europe, which is generated from oil or fat, and these type of diesel are extracted from soybean, sunflower, rapeseed, etc. using the process called transesterification. So it is a chemical process that exchange alkyl group with alcohol using a catalyst. So next is a figure which shows the biodiesel cycle. So it starts with the photosynthesis. So during photosynthesis, carbon dioxide from the air is absorbed, and due to the photosynthesis, seeds are generated, and these seeds are used for making crude vegetable oil. The crude vegetable oil is then refined, and then the process of transesterification takes place and biodiesel is generated, and this biodiesel is used by the vehicles, and the carbon dioxide again in the atmosphere is used by the plant. So the cycle continues. And now the advantages of biofuel. First is the efficiency. Biofuel is produced from renewable resource and relatively less flammable than fossil diesel. Next is the cost. The cost of biofuel in the market is same as gasoline. As the demand for biofuel increases, it is also possible that they will become cheaper in the future. Next is the durability. Biofuel are compatible with all the current engines and work well in most conditions. And fourth one is easy access to resource. So biofuel are mainly derived from manure, crop waste, algae, plant grown specifically for fuel. So it is easily accessible. Next is it will reduce the greenhouse gas emissions. So study shows that biofuel decrease the greenhouse gas up to 65%. Next is the disadvantage. So disadvantages, first one, food shortage. Biofuel are obtained from crop and plant that contain large amount of sugar. So most of these crops are accepted as food products. So if it is used for making biofuel, there will be considerable reduction in the food crops. Next is the weather limitation. Biofuel are less suitable for application in low temperature. Next is use of fertilizer. So excess use of fertilizer is needed to grow this type of crops. So next we will see the energy derived from ocean. The ocean thermal energy or the ocean thermal energy conversion is an electricity generation system. So OTEC is a process that uses the temperature difference between deep cold water and the hot surface water to generate electricity. There are mainly two type of OTC, open and closed type OTC. So the efficiency will be more when the temperature difference is greater. So this OTCs work. If there is great temperature, the efficiency of the system will be greater. So first is the closed cycle system. That is the closed cycle OTEC. So in closed cycle OTEC, the working fluid is used to transfer heat from warm ocean water to generate the electricity. So the warm surface water passes through the heat exchanger, which evaporate the working fluid. So first the water is pumped to the evaporator. The vaporized working fluid expands and drives a turbine which is connected to the generator, that is shown in green color. And the working fluid then passes through the condenser where it condenses back to a liquid. So this liquid working fluid is pumped back to the evaporator to complete the cycle. So the main working fluid used in the closed type OTEC is ammonia. So this is the process. So warm surface water is used to generate the electricity. Warm surface, that is heat from the warm ocean water is used to generate the electricity. So the warm surface water passes through the heat exchanger which evaporates the working fluid, that is ammonia. The vaporized working fluid expands and it will rotate the turbine which is connected to the generator. So now the vaporized working fluid again passes through the condenser where it condensed in a liquid form and it has pumped into the evaporator. So the cycle continues. So next one is the open type OTEC. So warm surface water is pumped into a low pressure container. So here you can see a container. So into that container warm surface water is pumped. So the pressure drop causes the water to boil and evaporate. So the resulting steam drives a turbine which is shown in green color. The steam is then exposed to the cold, deep seawater where it condenses into fresh water that can be collected and used. So here the main working fluid is water vapor. So after condensing, the fresh water can be collected and it can be used. So the main drawback of OTEC system is a large flow of hot and cold water can alter the local or global weather patterns. So this is the process. So warm surface water is pumped into a low pressure container where the pressure drop causes the water to boil and evaporate. The resulting steam drives a turbine that is attached to the electrical generator. The steam is then exposed to cold, deep seawater where it condenses into fresh water that can be collected and used. The working fluid is water vapor. So next we will see geothermal energy. It is the energy stored in the earth and is generated by natural source. So deeper you go, the hotter is the earth inside. So the core of the earth is very hot. So it is generated from the earth core, that is 4,000 miles below the surface. The main reservoirs are geyser, boiling mud point, volcano, hot spring, etc. So the figure shows a geothermal plant. This is the indirect usage of geothermal energy. So a well is drilled into the earth. So you can see a well is drilled inside the earth surface. So below you can see magma, a layer of magma, then rock heated by magma, and the water near it is very hot. So a well is drilled into the earth and water in the well is heated due to the earth warmth, and the heat pump is used to take the heat from the underground water, which can rotate the turbine, which is shown in figure 3. So this turbine generates the electricity, which can be used for various purposes like drying, space heating, greenhouse, air condition, etc. And after the usage, the water is then cooled and is injected back to the earth. And most of this geothermal activity occurs in an area which is known as the ring of fire. So here the process is explained. So a well is drilled into the earth to extract the hot water or steam from the underground reservoir. The hot water or steam is then piped to the surface where the pressure is reduced, causing it to turn into steam. This steam spins the turbine that generates electricity, which is then sent to the generator. The cooled steam is then condensed back into water and pumped back to the earth to start the process again. The geothermal heat pump is used as a heat sink or source of heat and cool buildings. Where the temperature above the ground is warmer, the ground absorbs the excess heat. When the temperature above the ground is cooler, then the ground acts as a heat source. So these are the uses of the geothermal power plant. So the generated electricity is used to provide hot water for the building, space heating or industrial process. And this geothermal power plant are most commonly found in area with a lot of volcanic activity, geyser, hot spring, etc., because they are area that is particularly hot just below the earth's surface. So these are the other usages of geothermal energy. So next we will see the tidal energy. The reason for tidal energy is the gravitational force between sun, moon and the earth. In order to harvest the tidal energy, the first step is to identify an estuary or bay with natural tidal range, and then it is artificially enclosed with a barrier. So this type would typically provide a road or rail crossing of the gap in order to maximize the economic benefit. The electrical energy is produced by allowing water to flow from one side of the barrage through the low-head turbine to generate electricity. So there are mainly two types of barrage schemes: single basin tidal barrage and multiple basin tidal barrage scheme. The simplest one is the single basin tidal barrage scheme. So that is shown in figure. So during the high tide, the basin fills with seawater and tide goes out. The water flows through the turbine and out to sea, which generate the electricity. The basic components of this is basic components of the single basin tidal barrage is a turbine, then sluice gate, slip lock. So barrage or dam is typically used to convert tidal energy into electricity by forcing the water through the turbine and activating a generator. So when the tide produces an adequate difference in the level of water on opposite side of the dam, the sluice gate is opened. Water then flows through the turbine and the turbine turns an electric generator to produce the electricity. So this is the basic working operation to generate the tidal energy. So thank you.